Okay, this is our final section for the year. This is Unit 7, Section 7, and we're going to talk about Pythagorean Theorem. I know that, because I've heard you guys talk about it before, that you've probably been introduced to this. So I'm not going to spend a lot of time explaining Pythagorean's Theorem. It has to do with right triangles. And in a right triangle, Pythagoras realized that there was a formula that you could find if you know two of the sides of a right triangle, you could find the third. And so the things you need to remember is that we have a right angle, and from that right angle, we have two legs. So this is a leg, and this is a leg. So the two lines coming that create the right angle are the legs. And then to make your triangle, we're going to connect the two legs. And that is our third side, and that's our hypotenuse. Our hypotenuse, no matter what, is always across from the right angle. Okay? So we also, Pythagorean, you could say leg squared plus leg squared equals hypotenuse squared. And so that's what he came up with. He realized that if you square one of the legs and you add it to the square of the other leg, it will equal the square of the hypotenuse. And you can actually hear this if you ever watch The Wizard of Oz. When the scarecrow gets his brain, he recites this. But we shorten it up and we name the legs A and B. So our legs are always going to be A and B. It doesn't matter which one's A or which one's B. What is most important is your hypotenuse is always C. Okay? And so really we have A squared plus B squared equals C squared, which I know most of you have heard that before. The difference now is we're not going to accept a decimal answer anymore. We want it in simplified radical form, and that's why this is coming into play in this unit. It's also kind of leading you into geometry because you're going to be doing this a lot with geometry next year. So this isn't the most difficult section of Unit 7, but it's necessary for next year. Okay, so let's do a couple of examples. So number one, if I give you a right triangle, let's see if I can draw it nicely. Now this is not drawn to scale, obviously. Okay, I have a right triangle. One leg is 8, the other leg is 15, and I want you to find the third side, which is the hypotenuse. So what I like to do is assign my letters. Here's my A, because that's one of the legs. Here's my B, that's my other leg, and I'm really trying to figure out what C is. So I take my formula, A squared plus B squared equals C squared, and I put in what I know. So A is 8, so that's squared. B is 15 squared. And then C is what we're trying to figure out. Okay? I get out my calculator if I don't know, and I do 8 squared is 64. 15 squared is 225. And you can do this in one step if you want. And 65 plus 225 is going to be 289. And that's C squared. We're not done though. That's C squared. I need to know what C is. And what do we do when we square both sides of when we want to undo a square? We square root both sides. Now, this is where this comes into play. When we square root something, we get plus minus 17. And plus minus whatever it is, in this case 17. So we get plus minus 17 equals C. That's our algebraic answer. We need our geometric answer. This is our algebra answer. Plus or minus 17, if we're not talking about something in particular, that works. Negative 17 is fine. But if we're talking about geometry, and we're talking about the length of a side of a triangle, there's no such thing as a negative 17 when we're talking about a distance. So we're talking about a length, so really C in this case equals 17. It doesn't mean that the plus minus just went away. It means we're thinking about the problem in context. And in context, this answer can only be positive. Algebraically, it can be plus or minus. Geometrically, we're talking about a side of a triangle. so it has to be positive. Okay, let's do another one. Make sure, oh yeah, this is a good one. So I'm going to draw the triangle a little different. See if I can draw it nicely. Okay, they're not always going to be facing the same way every time. Okay, what you have to decide and what will be given to you is the right angle. As soon as you have your right angle, you know where C is. C is always going to be across from the right angle. What I mean by across is draw an arrow from the right angle to the other that's across from it. And so this is my C. Once I know my C, my A and B can come into play. Ooh, I forgot to put the numbers in here. So let me put the numbers that this will be given to you. This side is 10. The long side is 25. And once I have those, now I'm just going to assign. So like I said, the hypotenuse is C, and A and B don't matter. So I'm just going to put A, B. The legs don't matter. Okay, which is which. And so then I do A squared plus B squared equals C squared. So A is what I don't know now. I don't know my A. So I have A squared. B is 10, so that's B squared. And C is 25 squared. So this is going to have a little more steps to it because you're going to have to solve for A. So we have A squared plus 100, because 10 squared is 100, equals 25 squared, which is 625. We're going to subtract 100 from both sides. I'm getting A by itself, solving an equation. Now I have A squared equals 525. Now, sometimes you're going to be asked for the decimal, but we're not going to be asking for the decimal. We want this in simplified radical form. So let's square root both sides. And so I get A equals plus minus, and now I need to prime factor 525. Lucky for you, I already did it. So it's 5 times 5 times 7 times 3. So what can come out of this is a 5. So A equals plus or minus 5 root, and 7 times 3 is left behind, so that's 21. Again, this is my algebra answer, which is perfectly great, but I'm talking about the side of a triangle. So my geometric answer is going to be only the positive 5 root 21. Okay, and a lot of times in geometry, you're not going to be actually giving the decimal. You're going to be giving the simplified radical form. Okay, so they're the two types of problems you're going to come up against in algebra, or in section 7. And that's our last section before the review. I'll probably do some type of video to review this chapter before we get to the test.